One of the key principles of creating an array and accessing its data is that you need to search for a specific item inside to it. So this searching algorithm that we are talking about is all about linear search. Linear search is one of the most common searching algorithm being used on looking at to the actual array that we have and comparing the actual data on what would be its current position. So let's have a reference with this kind of array. The array has 5 elements, which is n, and its index is represented from 0 to 4, while the position is represented to 1 to 5. So this is very important when you are trying to resolve a certain data or show if a certain data is currently in a list. In order for us to show the current position of the array, we can reference its actual position or can be referenced to its actual index. But it is in a manner that a user needs to understand on what would be the position. You need to consider the position of an array. So how does a linear algorithm search? Okay, so the linear search has the following principle. Suppose that we have a data of x to be searched on the actual array list, and the value of x would be 7. Okay, so you look at the actual data, traverse it through all of the data. Is it x equal to the array sub 0? Okay, let's represent this one a as the name of the array. So we will be comparing all of those data x to the actual index data of an array. So if x is equal to the actual index of an array, therefore you will say that it is found. However, if the record is not existing, or the data is not existing on the actual array, you must inform the end user it is not found. Okay, so how do we do that? How do we do that? Basically, a linear search or linear search algorithm, it compares all of those data through the value of x for each index of an array. So having an array with a 5 element, you need to compare all of those data to this x. Okay, take note, if the data is not existing on the array, you will be comparing it through all of that data. So how do we do that? So first is that on the initial element, x is equal to 7. Is it x equal to array sub I? So let's say array sub I is represented by its index. So let's put 0. Okay, is it 7 equal to the value of array sub 0? So array sub 0 is represented by the value, or the data is 10. So basically, you can look at the actual data, it is not equal. Since it's not equal, you will be incrementing the actual value of the index. So you go to 1. So you add by 1, so you'll be having 12. Okay, so array sub 1 is equal to 12. So therefore, 7 is not equal to 12. So what will happen is that you increment again to that data. So you increment, so it become 2. So array sub 2 is equal to 8. So 7 is not equal to 8. So we'll be continuing our searching. Okay, so we'll be continuing our searching. So 7 is not equal to 1. So therefore, it generates the actual value, or it compares the actual value of 7 to the entire element of that array. So basically, if you look at the actual representation of linear search, it does comparison. However, the good thing about a linear search is that when it sees the actual data, it breaks the actual algorithm. It stops the actual searching and represents the actual data by its position. So it's up to you. What would be your technique? If you'll be looking at the actual position, or you'll be representing it by its actual index. So now, suppose that we have a value of x. Okay, so suppose a value of x is equal to 8. Okay, so you will be comparing it until such time the value of value of x would be equal to the actual value of the index. Okay, so now we'll be going to array sub I. Okay, array sub I is equal to 0. I sub 0 is equal to 10. So it's not equal to 8. A sub 1, is it equal to 8? No, because a sub 1 is equal to 12. So we proceed with the actual data or comparison. So is it x array sub 2 is equal to array sub 2 is it equal to the value of x? So if you look at the actual comparison here, it becomes equal. Okay, so now it becomes equal. So what will happen? Since we have already found that x has a existence on the actual list, it doesn't need to compare the value of x to the remaining position or index of the array. So no need to do that. No. So you need to break it. Okay, so there will be a break. Okay, so there will be a break. So now, representing the actual data or representing the actual linear search into code, you will see that it will have a iteration. Basically, if you're accessing a data or an array inside a loop, inside a array, you need to represent it by array. Okay, so take note, x must be equal to the actual index, actual array value with its corresponding index. Okay, so how do we do that into code? Okay, so let's do it. Okay, so let's convert the actual algorithm into a code using Java. So basically, we'll be creating a class. So what I'll be creating is the class, which is the name of the actual file, which is linear search, and then with the public static void main. This is basically one of the requirement in Java in order to run the actual program. Public static void main string args. Okay, so then afterwards we'll be creating the actual declaration of the variables. Let's say the array, we'll be saving the array in array is equal to the actual name of the array and then the data that we have on our tutorial. So 10, 12, 8, 1, 2. Okay, 10, 12, 8, 1, and 2. So enclose with semicolon, and then in order for us to search it, we'll be having a position. We need to keep track what would be the position, or let's say we need to keep track if the actual data is already found. So let's say found is equal to 0. In this case, if 0, then it is not found. So for us to run, we need to have the x, the value of x. Let's say the value of x is 8, and then we traverse or we iterate through all of the item of the array. So for int, let's say let's represent the value of the index is equal to 0. Take note, an array starts with its index to 0, and then while for int idx is equal to 0 and idx, okay, less than the actual array dot length. Okay, the length of the array, and then we increment x idx by 1. So now, in order for us to compare if x is existing on the actual data of the array, we need to have a checking. X is equal to the actual array and corresponding index represented by idx. So if it is equal, take note, we need to break the actual code. Okay, break. So stop searching regardless if the length of the array is not yet met, or the condition here, idx array.length is not yet met. So break, and then system.out. Okay, system.out.print ln to show record found. Okay, so if it is record found, so what we'll be doing is to show the position. Okay, position is equal to the actual position, so we put idx plus 1. Take note, position is plus 1, and then we assign the value of found equal to 1. So since it's equal to 1, it will be running the actual code. It will change the value of found to 1. Then it would be our reference on the bottom part of our if condition or for loop if it is found or not. Okay, found is equal to, found is equal to 0. Therefore, we put a condition system or message system.out.print ln, then we put record found, not found. Okay, so let's see how does our code do. Okay, so let's compile it. Okay, don't be afraid if there's an error. Just need to double check it. Now there's no error. So let's see, Java linear search. Okay, so it record found position is 3. So let's see, 8, 1, 2, 3. And if we change this 1 to 11, okay, so it must be record not found. Okay, so let's see, Java linear search. Oh, so record not found. So it's now working. So basically, the algorithm or the program, what it does is that it compares the value of x until such time it finds the actual index of the array that is equal to x. However, if it is not equal to x, found will not be changed. Then it would be referenced on the actual checking if the record is not found. So found, if found is equal to 0, it represents that it's not found. But if found is equal to 1, so the actual value of the data or x is found on the list of array. So that's how our codes work with corresponding with linear search. So thank you, God bless, and happy coding!